The second video and lesson that you're going to learn about is the introduction lesson to congruent triangles. For two triangles to be congruent, just like for two line segments or two angles to be congruent, they have to have the same shape and size. So the two triangles on the very top of your sheet, triangle ABC, triangle DEF, they are the same size and shape. If I take one of them and drag it over the top of the other, you can see that they lay on top of each other. Also, the side lengths and angles that lay on top of each other are called corresponding parts. So in these two triangles, angle A and D would be considered corresponding parts. Angles B and E would be corresponding. Angles F and C would be corresponding. Also, the side lengths that lay on top of each other would be corresponding. AB and DE, BC and EF, C and DF. They would all be considered corresponding parts. Whenever you have two congruent triangles, there are 6 corresponding parts, 3 pairs of angles and 3 pairs of sides. Moving down, first theorem we're going to talk about is third angles theorem. If you have 2 corresponding angles in each triangle that are congruent, that automatically makes the third set of angles congruent. So in the 2 triangles that you're looking at, if one of the triangles has an angle measure of, say, 50 degrees, and another angle measure of, say, 80 degrees, that would be also true then for angles D and E because they're congruent. So D would be 50 degrees, E would be 80 degrees. If you add those together, A and B, you get 130, which would make angle C 50 degrees also. If you come down and look at angle F would also have to be 50 degrees for that same reason. Therefore, if angles A and B are both congruent to angles D and F, that automatically makes C and F congruent. The next thing is, in the next problem, is to list, once you have your congruence statement, which is what this is that I'm circling, you can now list all of your corresponding parts based off of that congruence statement. So if you look at the congruence statement, triangle JKL and triangle RST, you'll notice in the picture that J goes first in the congruence statement, and so does R. And if you look at your picture, J and R are corresponding angles. Same thing is true about angle K and angle S. If you notice, they both go second in their congruent statement. And the same can be said about L and T. They both go last in their congruent statement. So each one of those pairs is a pair of corresponding parts. Angle J congruent to angle R, angle K congruent to angle S, and angle L congruent to angle T. So even without the picture, you would still be able to match up the angles that are congruent in one triangle to the angle it's congruent to in the other triangle. You can also do the same thing with the side lengths. Notice that J and K are the first 2 letters in the first congruent statement, and R and S are the first 2 letters in the second congruent statement. That means in my picture, side length JK and RS should be congruent to each other. And if you look at the picture, you can clearly see that they are. If you look at side length KL, notice they're the last 2 letters in the congruent statement, and ST are the last 2 in the congruent statement. If you look at your picture, you can see that KL and ST are also congruent, and the same thing with JL and RT. If you look at J and L, they go first and last in their congruent statement. R and T go first and last in the congruent statement. Therefore, side length JL and side length RT would be considered congruent, and their corresponding parts. If you look down at the next problem, number 2, you can see that you would clearly be able to list all the corresponding parts because everything is clearly labeled. Angle B has a single arc, angle D has a single arc. They go together. C has a double, E has a double. They go together. A has a triple, F has a triple. They go together. Same thing can be said about the side lengths. BC has a single tick mark, as does DE. AB has a double, FD has a double. AC has a double or a triple, and FE has a triple. So what does it mean by write a congruent statement? Congruent statements are when we see something like this. Triangle whatever is congruent to triangle whatever. So how do I write my congruent statement correctly? The first name can be written in whatever order you want. So if I wanted to write the first triangle as triangle CAB, that would be fine. You'll notice that your book usually writes the names in alphabetical order. So what we need to do is make sure that the other triangle matches the same order.
6, 3.
So if angle C went first in the first one, then its matching portion, which is E, would have to go first. If A went second, then F would have to go second. And if B went last, D would have to go last. So that's one example of a congruent statement that you could write for these two triangles. If we flip over to the back of that sheet, the top tells you that in order to prove that two triangles are congruent, as of right now, we have to show that all 6 corresponding parts of those triangles are congruent. So that means that every single set of sides and every single set of angles have to be proven that they are congruent. Now, a lot of pictures, like the one given on the right-hand side, have a lot of the information pre-given to you. So if you count up all of the different congruences already given to you, you'll notice that you have angle G over here on the right, or on the left, E on the right, both angle F's on the bottom, and angle D on the top. Notice they've already given us all 3 pairs of angles as congruent. Similarly, they've told us that side length GF and EF are congruent, and they've told us GD and ED are congruent. So the only thing that I don't know about each triangle is the third pair of sides. So let's go through and we're going to list all the corresponding portions first that we already know. So let's start with the side lengths. We said GD in that picture is congruent to ED in that picture. We said GF in that picture is congruent to EF in that picture. Also, we can say that angle G is congruent to angle E. We can also say that angle GDF is congruent to angle EDF. We can also say along the bottom that angle GFD is congruent to angle EFD. And notice those last 2 sets of angles we were not able to just call angle D because there are actually 3 angle Ds at the top of my picture. There's the small piece on the left, the small piece on the right, and the entire thing overall. So you cannot just name that angle D. Also, the same thing is similar on the bottom. You can't call those angle F because there's an angle F on the left side, an angle F on the right side, and an angle F overall. So you can't call any of those just simply angle F. They have to be named with 3 letters. So the last thing we need to discuss is that we have 5 congruent parts right now, but it says to say the triangles are congruent, we need 6. So what we need to notice about this picture is that each of these triangles has side DF as its third side. They share this side down the center. There will be a lot of pictures in this unit that have a shared side like that. So what we can say is, in the triangle on the left side, that side length is DF, and the triangle on the right side is also DF. Well, we know by reflexive property that the last statement we just made is a true statement. We can say that something is congruent to itself. So since those triangles share that side, we can say that they're congruent to each other. So part B wants you to say, are the triangles congruent? The answer is yes. And the reason why is because all 6 corresponding parts are congruent to each other, all 3 pairs of angles, all 3 pairs of sides. And it wants you to write a congruent statement. So what we have to do is match up the letters in the triangle on the left side. So if I named it something like DGF, the triangle on the right side would have to match. Angle D matches with itself, angle E matches with G, and angle F matches with itself. So that would be the congruent statement. Now, can those be shuffled around? The answer is yes. However you shuffle the first name, the second name would have to be shuffled in the same manner. The bottom, number 8, wants you to determine whether you have congruent triangles. So if you look at the picture, you notice that all 3 pairs of sides are congruent. So what we have to do, and our responsibility, is to show that all 3 pairs of angles are congruent. So we're going to mark them off, and I'm going to show you why each set is congruent. The most obvious pair in your picture are the vertical angles here in the center. So what I'm going to do is name those angles, angle LJK, and angle GJH, and they're congruent because of vertical angles theorem. So that's one set of angles that we did not previously have. A second set of angles comes from the fact that these lines up top are parallel to each other, and if I draw in my transversal, that picture in blue should look similar to something you're used to seeing from the last couple of units, and I've got a pair of alternate interior angles here that are congruent. So in my picture, I can say that angle K is congruent to angle H by alternate interior angles theorem. So unfortunately for all of you, those theorems don't go away even though we're done with that unit. So I'm going to erase that now so that we can focus on a different set of angles. So we said originally that these 2 verticals were congruent, still true. These 2 alternate interiors are congruent, still true. The last thing I'm going to point out is again with my parallel lines, but this time I'm going to draw a different transversal. And from what I just drew in black, you can see, hopefully, that angle L and angle G are also alternate interior angles. So we can say angle L is congruent to angle G by the exact same reason as above, so alternate interior angles theorem. So what we've been able to show is that all 3 pairs of angles are congruent. They were given that all 3 pairs of sides were congruent, and that's our 6 pairs. So yes, the triangles are congruent. And what we're going to do is name each triangle using what matches together. So my congruent statement would say something like triangle, if I did the top, JKL. And I need to make sure that the bottom one matches also. J would go first again. The angle that matches with K is angle H. And the one that matches with L is angle G. And so we can write a congruent statement that says they are congruent. The bottom one and last one, I'm not given anything about these triangles except all 3 angles in one of them and 2 of the angles in the other. So if I wanted to find this missing angle, it's a triangle, and we know from the last lesson that if I subtract the 2 that I have, I will get what's left over, which is 38 degrees. Now if you'll notice, angle A and E are congruent, angle D and C are congruent, angle B and F are congruent. Is that enough information to say that I have congruent triangles? The answer is no. Since I don't know anything about the side lengths, I would have to say that this is not enough information. These triangles could very well be congruent, and in fact they look like they are, but because it looks like it is not a valid reason in geometry. Please make sure that you have any questions prepared for class so that if I ask for specific questions, you can tell me what did or did not make sense to you while watching this video.